All right, we are launching. It is April 7th, Wednesday, about to go into inception mode, verifying broadcast. April 7th. Welcome back. Double broadcasting in game and on YouTube until I see everything start going nuts. How are we doing? There it is. We're going nuts. Boom. Okay, first thing I'm going to do is stop double broadcasting. Just broadcasting in YouTube now. And now I am leaving Inception. All right. Good morning, everyone. Good to see you coming in. Let's run through our checklist. I'm going to go over here to read it. You can come over if you want, or you can follow along in your seats. Oh, sorry. I'm bumping everyone. All right. Make sure you've got your VPN activated so that you can speak if you need to in game. Find a quiet location so that you can participate without too much background noise. Tell your roommates that you are in class so that they know what you're up to and they can stop broadcasting their telenovela at volume 11. Turn off notifications on your phone and computer. I need to do that as well to make sure you're not getting constant distractions that impact your cognition and ability to understand anything deeply. It is a fact of modern life that we have to be aggressive about managing interruptions, or we are taken down paths that we don't get to control by the software around us. All right, put on your headphones, shut down any extra apps or browser tabs that you have. So I'm going to run through that, make sure that extra things that I don't need are shut down, like mail I don't need right now. That takes resources. I don't need my note-taking app right now. I don't need my to-do list right now. I don't need a spreadsheet right now. And I don't need preview right now. Everything else I need. Oh, I do need preview. Hope that doesn't quit on me after all. Okay, boom. Next one, make sure you got Canvas open. We're going to look, you're going to need that in a sec in order to work through some of the drone world that we're going to be working on today. Open Firestorm. While you've got Firestorm open, let's rebake our avatars. Avatar health, rebake. Make sure that you've got your draw distance down to a reasonably low number so that things are responsive. Got 288 for me. Make sure you're in the classroom. Make sure you can see your classmates' names. Check in at the attendance machine. Let's make sure it's working. Looks like it's working okay. Great. All right, and then we can go take a seat. All right, a couple announcements for today. So first thing is that I was able to grade assignment 15 over break, which is the polynomial class assignment, linked list and managing polynomials. I think that it was overall class did okay. I don't think any there weren't there wasn't there was a lot of people were struggling with this one. And I think that the main thing that people were struggling with was how to simplify polynomials. So trying to make that connection between what a polynomial is and how it works mathematically, and then trying to get the software to do the same thing. And so I'm not quite sure whether the disconnect was in what a polynomial is and how it operates, or whether it was in the software. In any event, those are done. So that's on the whiteboard behind me. And then there are answers over here on this fax machine on the far right. So a couple things in the answers. There's a solution that you can look at, and then there's also some test software there as well. So if you want to see the things that I tested you on. And then we've got a couple things floating around here. All right. On the screen behind me is just a piece of artwork that was by an artist whose Instagram tag is Shin Happens, and this is just an Easter piece he made for Easter a couple years ago. I've got a paper version hanging in my office. I really like it. And then he's got another one that he did this year that I encourage you to check out. All right, looking around the classroom, I see we got Frank, Trent, Ethan, Sam, Thomas, Adeline, good to see you, Faith, Taylor, uh, mm, going on with Taylor there? You're like a floating name tag, Taylor. Not sure what's going on with that. Um, all right, Carson, Dee Dee, Ben, Landon, Matthew, alternative seating arrangement, Morgan, Josh, Ben, and Luke. All right, good to see everyone. All right, welcome back from Easter. I hope everyone had a nice break. It was busy for me, but good to change pace a little bit. Hope everyone is, you all are, I think vaccines are open for folks your age now, or if they're not now, they will be very shortly. So something to look into. myturn.ca.gov is the place to go for California vaccination sign up if you're interested in participating in that, which I encourage you to do. I've had one of mine. I get my second one in April 13th, I think. Today, we are going to do something slightly different. Let me pull up a calendar for us and broadcast that calendar. I'm opening another tab. I'm getting the calendar. I'm putting it down on the screen. And I'm making sure our class is selected. There we go. All right, today's Wednesday, April 7th, and you can see today we are doing intro to drone assignment work. There is, in addition to checking in at the attendance machine, there's also a daily work activity today that will be on Canvas. I'll just launch that right now. It's a little, I feel like I'm launching a little prematurely, but there we go. We'll just do that. So that's launched on Canvas. You can track that down, or I'll drop a link in game. There it is. That's just the Canvas link. Waiting for my windows to rearrange. There we go. All right, so what's happening from this point on in the rest of the class is the programming assignments are shifting. So our programming assignments are no longer going to be associated with a chapter in the textbook, although we will still be going through different chapters and the content that we are reviewing will be evaluated through the Techni assignments. But we're going to be doing our programming a couple different ways. One way is going to be in class. We'll be doing some programs. In particular, I'm thinking of one in the recursion lineup. We'll be making a Sudoku solver as kind of a workshop for the class instead of a lecture. And then you've got 3 assignments due on Mondays, which is the drone challenge assignment. And so today what I'm going to do is orient you to the drone software so that you can get a sense of what you need to do. So it's really important, I guess the degree to which you're able to follow what I'm doing today is going to reduce the amount of difficulty you have in making these assignments work. So a couple things that you can do in order to make sure you're following today is you can get Eclipse open and ready to work with software. We're not going to be sharing via Saros today. Instead, we're going to be using something called GitHub. GitHub is a website that hosts software. It uses a particular kind of software management called Git, G-I-T. And this was written by the same guy who leads the Linux project, Linus Torvalds. He wrote this program Git as a way to manage collaborative software editing. And by that I mean software in which many people are contributing to writing of the software, because that's kind of the nature of the Linux operating system, is it's a volunteer operation. And when you have a bunch of volunteers working on software, it's hard to coordinate all the work that they're doing, especially if you have a package of software that has hundreds or thousands of source code files all working together. They all have to be compiling together. They all have to be bug free together. And yet you also have hundreds and maybe thousands of people contributing to the software. So he wrote the Git software program in order to manage that. And it's basically, it's called a version control system. And what it enables you to do is it enables you to have different people working on different kind of timelines of the software. If you like know the Marvel universe kind of idea of timelines where someone goes back in time and changes something and creates a branch in time, that kind of thing. That's exactly what Git does. It enables you to start editing software and go in a different direction, and have another person go in a different direction, and you make edits to all the software. And then later on, when one person is done with their feature, you merge it back together, and then you continue going on in that way. We're not going to be using anything so elaborate in collaboration, but we're just going to be using that in order for you to get the software, because the software is hosted on the website GitHub, which is a centralized place where you can get software using the program Git. Fortunately, Git is built into Eclipse, so you don't have to have another piece of software to do that. And we're going to walk through that today. All right, so let's start by, I'm going to open up the PDF that's listed in Canvas, and we can start by walking through that. I'm going to download it. I'm waiting for it to download. There we go. And I don't want all this on my screen right now. Just want a few. Okay, so we've got 3 assignments, and this is version 1. So for Drone World 1 assignment, here's the backstory. The year is 2030. There's been a dramatic shift in the transportation industry from gas-powered vehicles to electric vehicles. Even as recently as 20 years ago, you would have only seen an occasional electric vehicle on the road, but today the roads are filled with them. In Santa Barbara County, 90% are self-driving, and those are mostly operated by Uber. Unfortunately, Uber's surge pricing has gotten a little bit absurd, and it costs hundreds of dollars to get from Westmont to Vaughn's. Many scrappy startups have attempted to compete, but whenever a competitor's vehicle is on the road at the same time as Uber, Uber assigns a robocar to get in front of the competitor's car and drive very, very slowly. Regulators have identified this as grandpa mode, and it has caused Uber's competitors to lose all their riders and go broke. But now, Westmont physics majors have teamed up with the chemistry department to create flying vehicles, demonstrated on the left and with the yellow background. They've extended battery life and can bypass the pesky Ubers and their malicious behavior. Unfortunately, they do not have the software to control them, and they're looking to you to solve the problem. So in this assignment, you're going to create a Java class that controls a drone in a simulated Santa Barbara and compete to provide the best service. So we'll go through the steps to set your environment up here in a second, but before we do that, let me show you what it looks like running. And so for that, I'm going to shift over to Eclipse. And I've got that open on another screen. Let's take that down here. And I'm waiting for everything to even out. There we go. All right. Settle out. All right, so boom, I was messing around with it this morning, getting it ready for you. So the software is here a package. You'll have something like this called Drone World. You'll see here this bracketed phrase next to it. Right now it says Drone World 1 for students. That's a reference to the Git repository. It's saying that this project is linked to a particular timeline in one particular GitHub location. So we'll have set that up in a sec. It has a source folder with all the source code in it. It has a couple other things here, including Maven dependencies, reference libraries, your Java 11, your JUnit 5. Has a couple other directories as well, which you're not quite as familiar with. So there's an assets directory that has a bunch of graphics and fonts and images in it that we use for the game. There's a binary directory that's generated by Java when you compile everything into jars, same as target. And then there's a lib library which which has some things that I've written to compete with you. When you run this project, you will run it as a Java application when you want to run it normal. There are lots of different classes in this project that have main methods to them. And so what this dialog is asking is, hey, of all the main methods that are present, which one do you mean to launch right now? And you want to launch the one called simulator. And it'll take a second to load up because what happens now is that the software loads up the graphics models and it loads up after we get our little splash screen here. It loads up the graphics models. You can see that happening down here in the console behind it. You'll get some warnings about sound because sound isn't implemented in this or there's a problem with it. It takes a few seconds to load up. And then when it launches, what you're going to see is you're going to see a aerial view of Santa Barbara with some particular locations called out with little huts. There's going to be some passengers that look like green ninjas that are waiting to be taken different places. And then you're going to see the drone flying around to pick them up and take them places. Let's eagerly await the rendering. Should be here in a sec. I think all the broadcast software I've got going on my computer is slowing everything down a little bit. I hope that's what's happening. Make sure we're still running. Yep, still running. Just believe, just believe, just believe, just believe. There we go. Great. All right, so there's the drone. It's taking off. It's flying to this location here. You can mouse around and move the view a little bit. So it flew to McDonald's. It is now, the drone's name there is Polaris. That's why it's labeled. It's going back to In-N-Out out there but on Hollister. It's looking for a Ninja. Didn't find any. It is flying to back to McDonald's. This drone controller might not be very smart, and it might just be flying back and forth to McDonald's and In-N-Out. It is. So like that's an example of something we hope you're going to fix the behavior of. Down on the bottom, what you can see is you can see some progress bars. So generic company is the name of the drone company that's currently flying, and you can see it has a score associated with it. And that score is how much time it's taken to deliver the passengers. You also see a green progress bar. That's the number of ninjas that are waiting. And so as ninjas get delivered, that progress bar drops down lower and lower and lower. And you'll see a green progress bar build up under generic co as it delivers different ninjas. If for whatever reason ninjas die, then there's a little tick on the progress bar for red, or it becomes black. And when ninjas are in the drone but not delivered, then they're red. So you'll see a multicolored progress bar there. All right, so to end the program, you can either wait till it runs out of time, which is quite a while, 20 million game seconds, or you can just shut the window. Now, we never believe any software unless we've written tests for it. So I have also written tests for this software, not for your controller, but for my software, because I wrote all this. So if you right click on the top of the project and you run as a JUnit test, you will know whether or not you've received all of the software correctly. It'll run a bunch of tests on the software that's there, and if you pass all of them, it'll all be green down in JUnit tests. You don't know what it's doing, but you do have some confidence that it's running correctly. So let's go back to our instructions for how we go about doing this. So you can actually go through these in Eclipse right now if you'd like. I'll kind of go slow so that you have the opportunity to set this up as we go. So the first thing that you need to do is you need to open Eclipse, and we're going to need to get the code for Drone World. So now let me show you on the web where this lives. If you go to github.com, you'll see the base of all the software. It's a pretty technical looking website. Then if on the URL you throw my username on the end, you go to the software that I have hosted on GitHub, and it's not highlighted here, but you should be able to find it if you dig in. Let's see. So if you dig into repositories, there's Drone World. Great. So you can click on Drone World, and you can dig into all the software that's present. Compare and pull request. Recent pushes. Okay, we're just going to let that be. Compare and pull request. Let me just think for a second. Hold on. No, that's because we're looking at master. Okay, everything's good. All right. So you can dig in here and look at all the different bits of the software if you want. But you don't actually have to go through here. This is just the place on the internet where the software lives. What you can do instead is you can go directly from Eclipse. So to do this, you'll import a new project from Git instead of from a file or instead of from Saros. So you'll go under File and Import. You'll select Git and then Projects from Git and then Next. So let's just take a look at what that looks like. Go into Eclipse. It's not going to work for me because I already have it imported, but if you go File and then Import, you look for Git here, and then you'll do projects from Git, and you'll select next for the wizard. In the instructions, you can see that it asks you to choose clone URI and then choose next. So let's see if that's an option. Yep, clone URI. Now the difference between existing local repository and clone URI is it's possible that you could have this software on your hard disk already. And rather than having Eclipse go out and directly connect to GitHub, it might just work through your local file system instead. But we're going to go directly from GitHub. So you'll select clone URI, hit next, and then you get a bunch of questions here about how you're going to get that software. So URI stands for Universal Resource Identifier, which is basically a URL. And here's the one that you want to use, https://github.com/djp3/drone_world.git. You can get that from the PDF that's linked in Canvas. The host is github.com. That's the server on the internet that's hosting it. And the repository path that you want is /djp3/droneworld.git. That, because this particular project has lots of different versions, that's the one we're interested in, and then you'll select next. Great. Let me see if I can get this far with you before I run into problems with already having the software. So for the URI, we'll put that in. Great. The host automatically got populated and the repository path got automatically populated and the protocol got automatically populated at HTTPS. That's great. All right, and so the next thing it's going to ask you to do is say, okay, well, which branches do you want to check out? Meaning, which of the different timelines of this software do you want to check out? And the one that you want to check out is for the first assignment. So the first assignment is Drone World 1 for students. And over time, I can update this and you can refresh your software if you want. But Drone World 1 is for the first assignment. Okay, so you select that and you're going to hit next. Let's see what's going to happen. Great. And now it's going to ask you, hey, where on your local hard drive do you want to store this software? Because while Eclipse is working on it, it has to have the files somewhere. And so, a reasonable place to put this would be something like in your home directory under Documents, under some place where you're keeping all of your files for CS-030, and then maybe a subdirectory specifically for Drone World. And when you select that, Eclipse is going to download the software from GitHub, and then it's going to bring it into your Eclipse installation as a project, like I already have it present there. I'm going to hit cancel because I don't want to overwrite or double book or something. All right, and then what you should get is this something a little bit like this. We're not quite ready yet to go, but that'll get you started. And you should see that the project name has this bracket notation over on the right, which indicates which of the Git timelines you're on. And it should be Drone World 1 for students. Okay, so the next thing that you need to do is you need to wait for the code to download. So that might entail looking down at the bottom here on Eclipse, looking for some sort of progress bar that says loading or building perhaps. And then the instructions, I thought I had, oh no, there it is, great. All right, so now the next step is to make sure that you got your software downloaded okay. And so the way we're going to do this is we're going to run our JUnit tests. This software relies on a library called JMonkeyEngine, which we used in the Pyramid project as well. JMonkeyEngine's been updated since the version we used in the Pyramid project, so we're kind of using a more recent version, so some of the lighting models are a little bit better, and there's some other features that we're not taking advantage of yet. But you may not have that on your computer, and so the next step to run after you have downloaded it from Git is to right-click on the top of the project, go down to Maven, and go to Update Project. So a quick rundown of what Maven is. If you're familiar with NPM from JavaScript maybe, or Python or Ruby or something, and Maven is like NPM for Java. What that means is it's another website on the internet that hosts Java libraries, all kinds of different libraries, everything from networking libraries, cryptography libraries, interface libraries. It happens to host JMonkeyEngine as well. And so what Maven is Maven is a way that you can provide some configuration to your project so that when you're running your software in Eclipse, you don't have to go and get all those libraries yourself. Maven is a way to when you configure your project to instruct how do I describe this? The project has a configuration file that indicates that you need these remote libraries in order for it to compile. And Maven can read this configuration file and it will go out and get the repositories from the location that you indicate. So when you right click and you go down to Maven and you say update project, what that's going to do is go out and get the recent versions of all the libraries that your project depends on. It's going to load them to your hard drive in a directory under your home directory called .m2. And it's going to store them there and it'll update them and then use them as part of your project. So after you do that, you're going to see a virtual folder here in your project called Maven dependencies. And if you open that up, you'll see all the libraries that were downloaded by Maven that are necessary for the project to run. So these are all the libraries that are downloaded. You can see the path where they are actually stored. And for me, that's users djp3.m2 and then so on and so forth. It's a place that if you have multiple projects that you're working on that use the same libraries, it only downloads it once, which is great. And all those projects use the same library. So you'll see Maven dependencies, that's there. And then the file that actually controls that is this file called pom.xml. I don't know what POM stands for. I bet the P stands for project and the M stands for management, but I don't actually know. XML is a particular file format. And you can look at this. If you open it, you can see what's in it. And the one thing to be aware of is when you open the POM file, there's a bunch of different ways of looking at it, and there are tabs that are at the bottom of the window, which is the strangest user interface. But the tabs are at the bottom, and the one that I work with is just the raw file, which is over on the right, which is pom.xml. And you can see a bunch of details here. For example, you can see that the JMonkey engine software is referenced. You can see a bunch of details about where to get it from, versions, a couple things about what version of Java you're using. Those all control Maven's uh, ability to load your project. All right, and then after you have right-clicked and updated your Maven, you can then run this project as a JUnit test. And instead of launching the simulator, it'll run all the tests that are present in your source directory. And if all goes well, if you downloaded the software correctly from GitHub and you got all your projects from Maven, you should have high confidence that the software is going to work as intended because the tests are all there. And you can do coverage if you want, but it's not going to be very meaningful to look at coverage on my code. All right, and if all goes well, then you will be able to run it as a Java application, and you'll see the skeleton code that I have run it as the Java application. And then it'll go through the process of building, ask you which main you want to run, and then it'll do the loading of the graphics assets, and then it'll launch it. There it is. All right, I'll let that go for a sec. All right, so what I'd like to do is I'd like to take 5 minutes and give you a chance to work through that process of downloading the software and anything you'd like to chat about. We will try and figure out what's going wrong with your connection to the software. For the daily work today, what I'm asking you to do is do a screen record of the drone world software running. So kind of what I showed you with the drone launching in the world and flying around. I want you to screen record that and upload it to Canvas to show me that you were able to get the software running in your own computer. And then at let's say 9:47, maybe 9:48, we're going to start talking about the architecture of the code and how you go about writing a controller within this existing code base. Okay, so I will be here on in-game in order to address any concerns that you have, and I'm going to switch to in-game audio. Yeah, yeah, I'll switch to in-game audio and stop recording audio for YouTube for this period of time. Okay, back to in-game broadcasting. So we went through a process of working with students in order to understand what sort of issues they were running into with launching it. And we encountered maybe three issues. The first issue was that the incorrect branch from GitHub was checked out. So you have to make sure that when you check out the branch from GitHub, you're getting drone underscore world underscore O1 underscore 4 underscore students. And if that works, you're going to see that here in the top of the project in blue. In Eclipse, where I have that highlighted, you'll see that on the right. And you should see that for the first assignment. The next issue that we had is when we tried to run this as a Java application, we weren't sure which project we wanted to launch in, which class we wanted to choose the main function from, and the one you want to choose is simulator, and that'll launch the program for you. The third thing we ran into was just that the program was running slowly because of the graphics models that are involved. And so we got a black window and it didn't look like the black window was working. In fact, what was happening is it was just taking some time to load models, and you should see progress in your console window as it's trying to load up results, as it's trying to load up the models while the window is black in JMonkey Engine. I'll show you how to speed that up in a sec. Um, just for what it's worth, let me show you what the console gives you here. You'll see a lot of information about what's happening to your drone, and then when the whole thing ends at the bottom, you'll see some results. You'll see how much time ended up passing. You'll see how many passengers were never picked up or who were picked up. 9 passengers were never picked up. You'll see generic company, which is the name of the default one, delivered 1 passenger in a total time of 194,900. 0 were killed, 0 were quarantined, 0 were still on board, and 0 were unaccounted for. So then we get results of who won. There was only one competitor here, so generic company won. So that's what's happening there. Okay, so now what I want to do is I want to switch gears and talk about the architecture of how this works. All right, and let's first work through the PDF, and then we'll go look in the code for a sec to see what's happening. This software is what's called an event-driven simulation. And an event-driven simulation, what happens is that you write software that gets method calls on particular events that happen. And when your class gets that method call, your job is to respond to the method call and to do whatever work you want to do on that at that moment, and then return from the method call so that the simulator can continue running. So it's kind of like maybe there's a your software is running maybe as a driver for a drone. You can imagine an Uber driver, and your software is the driver. And every now and then, your driver is going to get a phone call, and the driver is going to get a phone call, and the phone call will be from the simulator, and the simulator will say, "Hey driver, there's someone that needs to be picked up. What do you want to do?" And the driver will say, "Well, I want to drive to the location." And then you hang up the phone, and the simulator is going to say, "Okay, I'll drive you to the location now." So you don't have continuous control. You get periodic control. When events get fired, you get to do work and then you return. A new event will get fired and then it will return. And because you have knowledge of when events get fired, you can make constructive decisions about how to work in the world. The other thing that happens is that because you have one object, and that one object is going to be the same object that's getting the methods called, these event-driven methods called, you can store data in that object in between events. So if you have an event call and you want to store some data, you can leave it as an instance variable. And then when your next event call happens, you can look at the data that was stored in that instance variable to make decisions. That's a framework. So just walking through the PDF here. Your job is to write the code in mydronecontroller.java, and then that is located under the reference package in the software, mydronecontroller. Bring it up. All right, the simulator is going to call the methods in your controller when different events occur. And so your methods can do any calculations that you want. It can store any information and any instance variables that you care about, all within your class. And then you will return from the method that was called so that the simulator can continue. Your class inherits from another class. The class that the class from which you inherit is called drone controller skeleton, and that's the parent class of your drone controller. So if you look in Eclipse and you look at my drone controller, you'll see that it extends drone controller skeleton. So you inherit from that class. That class happens to be in the same package. So drone controller skeleton. You'll see that drone controller skeleton has every single event implemented. Every single event has been implemented in the skeleton. And then in the drone controller that you get, only one has been, I guess maybe, yeah, only one has been implemented, which is drone idling. Oops, let me undo that. Um, and so what happens is when the simulator fires an event, it's going to call your drone controller. It's going to call the method associated with that event. If your drone controller hasn't implemented it, then the parent class is going to pick up the result. If your drone controller has implemented it, then your drone controller is going to intercept that method call and your parent class will never get called. It's just standard way in which polymorphism and inheritance works. And this is an example of how it gets used in the real world. Oh, side note here. One of the bits of feedback that we get from companies out in the real world, I feel like maybe I've said this. I say this from time to time. Forgive me if I'm repeating myself. Is that students coming out of computer science programs often only have experience writing programs from scratch. And when you go into the real world, you're never working on a program from scratch. You're always dropping into a company's software base. Rarely, if ever, you're making something from scratch. So this whole experience of working with existing software, writing features and working with someone else's design is very close to the kind of work that you do in industry when you're working with an existing code base. So on the one hand, you're working on algorithms, the algorithms that are going to be controlling the drone controller. That's sort of the academic bit. You're also learning Java, right? So that you'll be using Java in this bit as well. So that's the laying the bricks, that's the building of the cathedral. And the other thing we're doing in this project is getting you used to working in the kind of environment that you work in when you're doing software engineering in almost any environment, whether it's research or nonprofit or commercial, whatever you're doing. So just backstory there. Okay, so you can override any of the methods in the drone controller skeleton class, and you can study the mydronecontroller.java to understand how that pattern works with one particular method, drone idling. Now, the normal way in which your controller is going to send messages back to the simulator is to call one of a handful of methods in your simulator class, which is going to communicate to the simulator how your drone wants to move through the world. And then the simulator is going to do the work of moving your drone. So like what you don't have to do is you don't have to do the work of moving your drone from position X to position X plus 1 to position X plus 2. You don't have to do any of that. The simulator is going to do that. What I want you focusing on is the higher level decision making. Which location do you want to go to? And then the simulator will get you there. So when your drone controller has had an event fired and your drone controller method has been called by the simulator, you then, within the body of your event handler, have the opportunity to call a couple different methods. If you would like your drone to go to a particular place, then you can call one of these two methods that are implemented by the simulator. You can call route drone, and you'll say which drone do you want to route, because eventually you're going to be handling more than one. And then you can say which place do you want to go to. And there are two different versions of this method, one in which you pass it the place that you want to go to. That's a custom class called place. And the other method that you can call is with a string, where you give it the name of the place that you want to go to. In the body of your event handler, after you call route drone, whichever is the last call in the body of your event handler, whichever is the last place that you send your drone to when you return from the event handler, that's the one that the simulator is then going to send your drone to. So if you route your drone within your code, you say route drone McDonald's, route drone In-N-Out, route drone Westmont. The only one that's going to stick is the last one that you call. Okay, the second thing that you have to worry about, the first thing you have to worry about is where you want your drone to go. The second thing that you have to worry about is what you're going to tell the passengers. And this is the idea that your passengers, where your passengers want to go and where you tell your passengers you're going may be different than where you're actually going next. This sounds deceptive, but in fact, it's just the way like a bus works. So if you were acting like a public bus and you stopped at a bus stop and your passenger wanted to go to Westmont, all they need to know is that eventually the bus is going to go to Westmont, even though the bus's next stop might not be that location they want to go to. So what the drone manifest is about what you want your drone to tell your passengers so that they can decide whether or not to get on board. because they're not going to get onto your drone unless you have indicated that your drone is going to the place that they want to go. And so there are three different ways that you can announce to passengers where this drone is going. Let's start at the middle one. The middle one, in your event handler, you say set drone manifest, which drone's manifest you're setting, and then you give it a string of which place that drone is going to. So when your drone lands, your ninjas are going to evaluate what your drone manifest is, and if that's the location they want to go to, then they're going to get on board that drone and then they'll fly away. And so the way that you control the boarding of the ninjas is by setting your drone manifest, not by actually getting them on or anything like that. The drones are smart, I guess. They're little people. The second way you can do it is when you set your drone manifest, you can pass it a place object. So this is an abstract representation of a place that includes the name, but other things as well, like its location and other information. Then the most interesting one maybe is the first one, because you can actually set your drone manifest to a whole collection of locations. And the way you do that is you pass it in a set, a Java util set, using a generic where the kind of thing that's in this set is a place. You give it a whole set so that when your drone lands, the Ninja will evaluate if where it wants to go is any of the places that you have said in the manifest, regardless of which one you're actually going to, and the Ninja will get on board your drone if it wants to go to one of the places that you've indicated. So for example, if you want every single Ninja to board your drone no matter what, then you could set your drone manifest to be the set of all the places in the world, all the places in the game. And if you say my drone's going to all the places that drones go to, the Ninja's going to find the place it wants to go to and it's going to get on board no matter what. Now that might not be the best strategy because you have a limited capacity for your drone. So like if your drone is already full, then no more Ninjas can get on. All right, so let's get down to some of that bits. Let me take a second. Let me finish this and then I'll have you ask questions about setting route, location, or drone manifest. So each time you call one of those methods in your event handler, it's going to override any previous calls to those methods. So like if you want to set your drone to multiple places, you have to use the version where you pass it the set. If you use the third version where you pass it a place, it's just going to overwrite the one place that you say that drone's going to. If you want it to go to multiple places, you have to use the first version and then not call it again. After calling those methods, your method needs to return from the event handler so that the simulator can continue the simulation of the world and act on your request. The two commands are different because where a drone is going and where the drone tells the passengers it's going is different. The passengers are going to board your drone if they want to go to where your manifest says you are going, and your drone actually goes to the place to which you route them. So those are two independent ideas, where you say you're going and where you actually go. If your method takes longer than 10 real-world seconds to return control to the simulator, then the simulator is going to put your drone into a quarantine state. Because what that means is that you've got bad code. So if you have bad code in your controller, like an infinite loop, the simulator is only going to give you 10 seconds to return your answer, and then it's going to say, hey, something's gone wrong. I'm quarantining you, and that drone is then taken out of game, set aside. If none of the I would be shocked if the amount of computation that you were doing in your drone controller actually took 10 real world seconds. So your concern shouldn't be writing fast evaluations. You're going to be plenty fast enough. Your concern should just be that you're not writing an infinite loop. So this is really just to catch infinite loops, not to catch like reasoning that's too elaborate. Your reasoning will not be so elaborate that it takes 10 real world seconds. All right, let me see what questions we have and then we'll continue. Pausing for questions. Okay, keep going. There are some things that you can adjust in the simulation, and these are going to be helpful for making it easier to do development. So this spans 2 pages here. You can say true or false whether or not you're going to use the same random numbers each time. So some of the like where the ninjas are at the beginning of the game is random. But when you're debugging, sometimes it's helpful to not have them change locations every time you run again because you need to try and figure out what's going wrong and you don't want the ninjas moving all over the place to debug. So you can set same random numbers each time to be true, and that will mean that every time you start your program, the ninjas are going to start in the same place so you can debug stuff. When I run it for the competition, I'm going to have actual random numbers that vary. High resolution can be set to true or false. If you set it to false, the simulation is going to start faster, and that's important for the debug cycle. Drone model count indicates how many different kinds of drones there are. So in the example that I showed you, you've just got one kind of drone. It was the one that looked kind of like the circle with the legs coming down. There are multiple different graphical models, and if you reduce the number that the simulator knows about, then it starts faster. The next one is simulator speed. The higher this is, the faster the simulator will go. Again, there's a balance between being able to follow what's happening and waiting for the simulator to do its work. And then the last thing is you can set true or false whether you want the simulation to actually quarantine drones. And the reason why you might want to set that to false when you're doing development is because when you use the debugger, if you pause the debugger in your event handler and you pause for more than 10 seconds, then the simulator is going to put your drone into quarantine, even though the reason why it took more than 10 seconds is because the debugger paused your code. So in the process of debugging, you might want to set quarantine drones to false just so that the simulator doesn't shut down while you're trying to evaluate what's going on. So those are 5 different things that help control your simulator. And when you look in the software here, you can see that they're also in the reference package. And if you open up My Simulation Controller, you'll see a bunch of constants written here, and you can change any of those you'd like. The first ones are relevant. They're set in a particular way. So let's say same random numbers each time. Be reasonable to set that to true for debugging. High resolution, if you set that to false, it'll start up faster. Drone model count, if you set that to 1, it's going to load up faster. Simulator speed, you can set it up to 100 to run really fast. Quarantine drones, you can set to false while you're debugging to figure out what's going on. And then simulation end time is how long it takes to run, or how long the simulation goes for before it just manually stops. So I changed those different parameters, and now when I right-click on the project and I run as a Java application, I'll get my JMonkey engine pop up. Oh, sorry, I got to run simulator. JMonkey engine, and then give it a second to, it does have a little bit of loading to do. There it goes. And it starts much faster, but the drones get replaced by blocks. And you can see it's just like starts flying around. And so it can be hard to kind of understand what's happening when it's moving that fast. So you can work with a combination of whatever parameters is helpful for you being able to understand what's happening. All right. Okay, so here are some things that are helpful to be able to make decisions about what the world is like. You might want to know what the list of all places are. So if you call get places as a method on the simulator, it will return a set of all the different places in the world. So all the different places that ninjas can be and all the different places that drones can go will be returned in that set. If you call get drones, you'll get a set of all the drones that are operating in the world. That might be helpful for you. If you call get people, you'll get a set of all the different people that are in the world, and that might be helpful for knowing where the people are. And so here's a way that you can call that from within your event handler. Within your event handler, you might say get simulator. That's going to return the simulator object. And then you'll call get places on the simulator object. What will be returned is a set of places that you can call in your local variable. You can call it places, and you can do whatever you want with it. Evaluate it, do a loop through it, save it in an instance variable, whatever you think is helpful. Those are calls on the simulator. On one particular place object, you can do a variety of different things. You can look at the code completion to see what's possible, but one thing you can do is you can get the name of the place. Another thing you can do is you can see which ninjas are waiting to embark. That means which ninjas are waiting to get on board a drone. And what that's going to return is a linked list of people. And so you can walk through. Now it's a linked list because it's a line, right? It's like a bank line. And so a linked list is appropriate for that collection. So the first person in the linked list is the first person who's going to be able to try and get on board the drone. And if the drone's going where they want to go, they'll get on. If not, we'll go the second person. When you have a person object, you can ask a couple things about the person object. You can ask what destination they're going to, and you can also ask what state they are in. And there are a variety of different states that the person can be in. If you have a state not being like a state like California, but a state like what state of mind are they in? The drones have a couple different options. You can get their state, like what the drone is currently doing. We're not dealing with charge yet, but you can see how much charge is in the drone. You can see what capacity they have. So for this first assignment, the capacity is going to be 1, but that's how many passengers they can have. And then you can get a set of who the passengers are on the current drone. So you can find out who's currently on the drone if you want to know that for your decision making. Here are the list of different states that a drone can be in. A drone can be in the begin state. That's where it is at the very beginning of the simulation. It can be in an embarking state. That means that the drone is currently loading passengers. The passengers get on board in groups, and it takes a little bit of time. You can find that out if you want. They'll continue loading until as long as the drone is not full, and as long as there are passengers that want to go where the drone says it's going. And then there's a simulator setting that says ignore that if you want. But after the drone is done embarking, then the drone ascends, which means it lifts off. It takes a certain amount of time to do that. After it gets to the top of its flying height, then it's in transit, where it flies to the next destination. The drone might be exploding. That means that it is in flight, but it has run out of fuel, and it's about to blow up. It is blowing up, and it's falling out of the sky, and all the passengers on board are dying. The drone might be dying. That means the drone has hit the ground after exploding. The drone might be dead, meaning the drone is no longer functioning. The drone might be descending, meaning it's gotten over its location and it's lowering, and that takes a certain amount of time. The drone might be disembarking, meaning passengers are getting off the drone. The drone then, it might be recharging, in which case it's charging up at the station on the ground. The drone might not have anything to do, in which case the drone will be in the idling state. And then lastly, the drone might be quarantined, meaning it doesn't get to play anymore. The people can be in a number of different states. A person can be waiting, a person can be embarking, a person can be on the drone, a person can be disembarking, a person may be where they want to be already. The person might have arrived. A person might be dying because they're in an exploding drone. A person might be dead because they're in a crashed drone. And a person might be quarantined because they were on board a drone that was quarantined, and so they're stuck. Here's a visualization of all the events that get called. I turned it sideways. This is the drone life cycle. And if you look at this, you can see the pattern of methods that get called. This is elaborate, but you don't actually have to deal with all of them. Our drone simulation starts at the left. Drones are put in the begin state. Then drones are put in the embarking state. And then the event handler drone embarking state is called on your controller. And then drone embarking a group start is called. And then drone embarking a group end is called. Drone embarking end is called. Then drone is set to ascending state. Then drone ascending start is called. Then drone ascending end is called. So each one of these moments, each one of these methods that are called are an option for you to make a decision if you want. If you don't implement it, then the parent class is just going to take over and just output something to the console saying it was called. It's in transit, it descends, it disembarks, it begins recharging, and then finally, if it hasn't been given a destination, it's in the drone idling category here. All right, so before we wrap up then, here's the rubric for drone 1. Your drone is going to run by itself in the world. You'll have no competitors. You will not blow up because the simulator will be set up so that you don't explode for running out of fuel, and each drone can hold 1 passenger. And so the grades here are, you'll get the best grade possible if you are able to deliver 10 of the ninjas faster than 4 other people or groups in the class. You're allowed to work in groups as well, groups of 2 max. If you deliver 10 ninjas before 5 million clock ticks, then that's an A. go down to like C, where you turn in a controller class that delivers at least one ninja to one destination before the clock tick fails. Meanwhile, over in my drone controller, you'll see an example of what's happening right now. I know we're right at the end of time. Let me just point this out. This drone controller only has one method implemented, drone idling. So this drone controller only does something when the drone has gotten to where it needs to be, where it has nothing to do. It calls it superclass. All that does is output the fact that it's idling. It gets a list of all of the places. It checks to see where it currently is, because it's when you're idling, you're at your destination. It removes that particular place from the list of places. It creates a new list of places from the list of places, set of places that's just made. It picks the first one from that list. It tells all the passengers that's where it's going, and then it goes to that location, and then it returns. So then the simulator takes over, sends it to that location, ascends, transit, descends, recharges, and when it's done, it'll call drone idling again, and it'll get a new chance to go through this process. All right, so it's gonna take you a little while to, you're gonna need to spend some time to work through the software and figure out what's happening and get a sense of it, but I think that is great for today's introduction. I will post this YouTube video on Canvas, and then I also have some archived tutorials walking through this process that are broken up a little bit. I'll leave those up too, although they might be dated now. Any last questions before we wrap up for today? Okay, so again, we've got 3 assignments. First one's due on Monday. Modifying the drone controller. Happy to help if you need it. That's all we've got. Welcome back. Thank you for your attention. Don't forget to sign in at the attendance board. Yeah. Broadcast. Try again. Shutting down. This is April 7th, 2021. Intro to Drone World Class 32, I believe. Thanks for attending.